Hello. So on the when we started this series, I said that we were going to build a fast DI container. I never actually showed any supporting evidence that it was actually going to be fast. I knew it was because it uses just functions and invocations on those delegates, but it has come the time to actually show some numbers. So let me show you what I built up for actually doing this comparison. And what you're gonna see here is a very simple console application. I have a domain model. I took this example from a Ruby weblog that is somewhere on the web. I don't remember the URL at this point, which explains how what dependency injection is for Ruby developers, and it has a very comprehensive and pretty realistic domain model where it shows that there is a web application which has dependencies on an authenticator component and a stop quotes component, and then each of those objects in turn have dependencies. So for example, the authenticator depends on a logger to log errors, to log diagnostics information, an error handler, and a database. Similarly, the stock quotes class has a dependency also on a logger, error handler, and database. And let's take, for example, the database. It's up here. Depends on logger and error handler, and so on. So it's a very interconnected domain, which is pretty typical. And basically I created all the classes. The behaviors are empty, so there's no overhead by running any actual code. So this is going to be like a micro benchmark, which of course you can argue that it's pretty useless, but nevertheless I'm going to do it. So we have the domain there, and then what I created is an abstract class, the use case, which has a simple method run. Each of the libraries that I tested, Funq, Ninject, Structure Map, Unity, and Funq, basically are composed of one use case. The constructor of the use case basically goes and sets up all the dependencies, configuring the container and the like. I am not using any kind of instance reuse, so every time I instantiate the model, I'm getting a new instance of the entire graph. I just want to test for the worst case scenario, so no caching, no nothing. And so this is a typical Funq use case. You're registering the lambdas, and I also tried to be fair with all the frameworks. I used lambdas as much as possible in all of them. All of them support creating these static registrations, as some call them, basically passing the lambdas that will construct the objects, which is the same that Funq is doing. So that makes the comparison pretty fair. And basically the run goes and pulls an instance from the container and calls run, which does nothing. My controller program can receive the number of iterations to run this, so you can run this on your machine if you want to, and basically goes, instantiates a use case, and then does a measure on the run. The measure for the run action is basically just doing a garbage collect before we start measuring, so that we don't pollute the environment with the objects that have been left from a previous run, and then uses the stopwatch, runs the action the times that you tell it, and then tells you how many ticks have passed. So as part of all the use cases, you can just look at the Funq one. It's very similar to the Funq because the API is inspired also by that. So Ninject has a kernel, then standard kernel. I created a sample module. This is the way I'm not an expert on any of the other frameworks other than Funq, which I really love. So if there's any improvements that can be done on the registration for the other frameworks, please let me know. This is for Ninject, so I'm also binding the types to methods. Okay, and they all use transient behavior in this case for Ninject. Plain use case is I'm just newing up the entire graph. Okay, so this should be is the fastest possible way in .NET. Just new up your objects, no DI. And structure map also I am using the configuration for the default is constructed by and the delegate, so that gives you an instance of that type, and you get to retrieve the instances from the context that is being passed when you resolve. The resolve is pretty much the same for all of them. They have either a get instance or a resolve. Unity, this is the Microsoft Patterns and Practices. It has an extension which is called Static Factory, and that's the one that allows you to basically go and register factories as delegates. And also the resolve is fairly straightforward. This was the only complication, like setting the default lifetime policy to be transient turned out to be a little bit involved. And finally the abstract one. So when I run this, I basically got the following numbers. Let's show up there. This is no DI whatsoever for 10,000 iterations of the action, and then how many times slower is to use that particular framework as compared to not using anything at all. So AutoFact 60 times, Ninjex 372, structure map 33, 78 for Unity, and 11 for Funq. And this is basically a relative comparison between Funq and the various frameworks. So Funq is 5 times faster than AutoFact, 28 than Ninjex, almost 3 than structure map, and almost 7 compared to Unity. So yes, it is the fastest one. Many people will argue that it's not. We're not comparing apples to apples because of the feature set, which is reduced for Funq. That's fine. The feature set that I implemented in Funq is the absolute minimum that you need to have some DI in your application, and that's what we needed for doing a high-performance version that can run on the compact framework. And as this shows up, it also benefits the desktop, of course. And so this is a small graph there. I'm gonna share this graph. Let's actually do it right now. tinyurl.com. Let's share this with the world. If it lets me. And always require sign in. No, nobody needs to sign in. There we go. Now I'll create a tiny URL for that. So the long URL. Let's put an alias DI performance or Funq performance. DI performance. Performance. So tinyurl.com/DI performance should get you the numbers. You can check out the source from Google Code and run the test for yourself and suggest any improvements or anything. So thanks. This proves that it was actually a fast DI container and you can use it right away. I'm still working out on building the binaries for Compact Framework 2.0.3.5 desktop Silverlight and Mono. So thanks a lot, and this was a fun ride for sure.